In this lesson, we're going to simplify radicals containing variables, containing variable expressions, and we're going to look at square roots, cube roots, and so forth. And so one of the properties we're going to use though is this property. We're going to use this property quite often, and this is called the product property. Product property for radicals. Okay, product property for radicals. And in terms of a square root, here's what it says. So if you have the square root of a times b, if you have the square root of a times b, if you have the square root of a product, see a times b, if you have the square root of a product, I can rewrite this as the product of each individual square root. So the square root of a times b, I can write as the square root of a times the square root of b. All right, and then the same thing if this was cube root. Cube root. The cube root of a times b, I can write as the cube root of a times the cube root of b, and so forth. So in general, you can make the statement that the nth root of a times b can be rewritten as the nth root of a times the nth root of b. Okay? Now, um, as we go through the process, the directions will say something to this extent. It'll say simplify each radical, simplify each radical. So each radical expression or each radical. It may say the word radical expression. Now, for us, we're going to assume this. We're going to assume that variables represent positive real numbers. All right, so we're going to assume that variables represent positive real numbers because there is a topic, and you will see this topic being discussed at some point. But there is a topic in which when you take the square root of a variable expression, you may have to introduce absolute value. And so we don't want to talk about this idea here. So we're going to assume that the variables represent positive real numbers, so that way you don't have to deal with absolute value expressions. Okay, so number one. And number one will basically be a review. So number one is a review, all right, in terms of this idea. So let's look at this example. We want to simplify the square root of x to the 20th, y to the 8th. Okay, x to the 20th, y to the 8th. All right, now, so according to the product property for radicals, I can rewrite this as the square root of x to the 20th times the square root of y to the 8th. So you see what I did? So the square root of this product can be written as the product of each individual square roots. And in a previous lesson, we saw that the square root of x to the 20th, remember the square root of x to the 20th, this expression means what expression times itself is the radicand, which is x to the 20th. And so you saw in a previous lesson that that's just x to the 10th, because x to the 10th times x to the 10th is x to the 20th. When you multiply like bases, you add exponents. 10 plus 10 is 20. So this right here is just x to the 10th. That's what that is. You also saw in a previous lesson that since the index is 2, square roots and the index is 2, and this exponent of the variable is even, I get a nice integer 10. So 20 divided by 2 is 10. Okay? All right. Now, this shortcut, by the way, you learned this property in a previous course, but there's a property that says this in a previous course where you talked about rational exponents. So let me go ahead and just put that on here. So rational exponents. Just kind of remind you about that. And you may have forgotten about that, and that's fine for right now. But remember this is what it says though, rational exponents. So this right here, like x to the 2/3, So 2/3 is a rational exponent. It's a rational number. Okay? And we saw in a previous course that if you have x to the a divided by b, x to the a divided by b, this rational exponent, no, assuming that b is not 0, um, nor 1, then I can rewrite this as the b root, so the index, the denominator is your index, of x to the a power, like that. All right, so you saw you could do that in a previous course. All right, so basically, see this right here? So a divided by b is this. So the exponent divided by the index is this. So you learned that in a previous course. You also learned, by the way, just to remind you, that see where I have the exponent a under the radical? I could have written it as the b root of a raised to the, I'm sorry, of x, excuse me, x, the b root of x raised to the a power. So you can put the exponent on the outside, or you can put the exponent on the inside. But that's something you learned in a previous course. All right, and that is going to be just as a review. This is going to be one of the topics, the next topic, something. It may be the next topic in this course, but we're going to use this only as a review in this course. This was covered in a previous course. You may have forgotten it, so it's going to be a review. All right, but that's important. That's an important property right there. All right, and so the reason I'm bringing it up is because that's really what you're using here. See this right here? So using this rational exponent rule, I can rewrite this as x to the 20 divided by 2. This right here. So a divided by b. So 20 divided by 2, which is 10. All right? Okay, so the square root of x to the 20th is x to the 10th. This is a nice expression also because 8 is divisible by 2, right? That's a nice one to deal with. So the square root of y to the 8th is just y to the 4th. And so there's our answer. Now, most students will go from here to here because that's an easy one to deal with. They can see right away that x to the 10th times itself is x to the 20th. Y to the 4th times itself is y to the 8th. Okay? All right, now let's look at number 2. Okay, so number 2, we have this in number 2. We have the square root of x to the 7th times y. The square root of x to the 7th times y. Now, using the product property for radicals, that's supposed to be property right here. Product property for radicals. I can rewrite the square root of this product as the square root of x to the 7th times the square root of y. So the product of each individual square root. All right, now this one is not as easy as this, right? Because the exponent here was divisible by the index. 7 is not divisible by 2. But let's talk about that. Let's go off to the side and kind of talk about that for a moment. Now we're going to deal with this in a couple of ways. It's important that you understand all those different ways that we're discussing this. All right, so let's look at the square root of x to the 7th. And here's one way I want you to think about this. Remember, it was nice if this exponent was even, because 20 divided by 2 is 10. And so that was just x to the 10th, and then the square root of y to the 8th is just y to the 4th. All right, let's use that same idea. So here's how you're going to think about this. What is the largest integer less than 7 that's divisible by 2? So the largest integer less than 7 that's divisible by 2 is 6. So we're going to rewrite this as the square root of x to the 6th times x. Because when you multiply like bases, you add exponents. 6 plus 1 is 7. Now I'm going to use the product rule. I'm going to rewrite this as the square root of x to the 6th times the square root of x. And now, see, this is a nice one now, because the square root of x to the 6th, 6 divided by 2 is 3. So that's x cubed. X cubed, remember this, x cubed. See, this right here is this because x cubed times x cubed is x to the 6th. Okay? All right, now let's talk about the square root of x. All right, so here's something I need for you to remember. Okay, so listen carefully to this. So you may say, well, what do I do with the square root of x? Well, first of all, notice the exponent. What's this exponent right here? That exponent is 1, right? And what's the index? The index is 2. All right, so listen carefully. A. All right, so note. All right, the the variable, let me write it, the radical expression, the radical expression, the radical expression, and I'm going to write this as the b root of x to the a power. So this radical expression is simplified if 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 a, the exponent, is less than b. So the radical expression is simplified, meaning you can't do anything else with this if the exponent of the variable is less than the index. Okay? So a has to be less than b. The exponent has to be less than the index. Less, not equal to, not greater than, less. Okay? So I want you to notice this. Let's go back over here. Was 20 less than 2? No. So I can simplify that. Was 8 less than 2? No. So I can simplify. Was 7 less than 2? No. I can simplify, and that's what I'm doing here. Okay? So, um, so I get the so I get the square root of x to the 6 times x, which is the square root of x to the 6 times square root of x. So here 6 is not less than 2, so I can simplify that, and that's a nice one because 6 is divisible by 2, so you get x cubed. Now look at this. X to the first. Is 1 less than 2? Yes. 1 is less than 2, right? So I cannot do anything else. So this right here goes here. So far, the square root of x to the 7th is this. So, well, the square root of x to the 7th is this. So I get x cubed square root of x. Okay? Now let's look at the square root of y. Can I simplify the square root of y? Yes or no? First thing you got to ask yourself that. First of all, can I simplify the square root of y? I can simplify the square root of y if I can simplify if the exponent is greater than or equal to the index. And in this case, it's not, right? 1's less than 2, so I cannot simplify that. So I'm going to rewrite it down. So square root of y. All right, so far I have this. This variable expression is equal to this. Okay? Then I took this part here and I simplified this as much as I can. So the square root of x to the 7th is x cubed square root of x. I cannot do anything else to this because the exponent is less than the index. So I bring it down. All right, now here's what you got to remember. So remember a while ago when I had the square root of a times b is equal to square root of a times the square root of b? Well, you can go backwards. So the square root of a times the square root of b is the square root of ab. So whenever the indices are the same, you can write it as one radical by multiplying the radicands together. So square root, so I can write this as x cubed square root of xy, and that's your answer. Okay, that's your answer. All right, now we're going to do another one. So it is a very easy process. We're going to do another one. All right, but look at the shortcut. I want you to think about the shortcut. All right, now you got to know both ways because it helps if you know both ways. If all you do is learn that shortcut, you're going to hurt yourself at some point. So look at the shortcut. 7 divisible by 2, 7 divisible by 2, right, is 3.5. Y'all agree? All right, so you see this 3 right here? That's this. Okay? And you see the numerator? That's that exponent right here. All right, let's do that. Let's do it here. So 7 divided by 2 is 3.5, correct? So 7 divided by 2 is 3, so there's your 3 right here. And that numerator, that 1, is this exponent. The 2, that in the denominator, is your index. Okay? All right, so that's a shortcut. So check yourself using that shortcut. Make sure you do it this way because that's where the understanding is. Use your shortcut to kind of check yourself. 7 divided by 2 is 3.5. And so 3 has to be the exponent on the outside, and then the numerator of the fraction is the exponent under the radical, and the 2 is the index, so square root. Okay? All right, let's look at another one. It's a very easy process. It's not difficult. Very easy to simplify radical expressions. All right, number 3. All right, in number 3, let's suppose we had this for number 3. Let me find where the problems are. All right, number 3. Okay, so here's number 3. We have the square root of x to the 19th, y to the 22nd. All right, x to the 19th, y to the 22nd. It helps tremendously if you first of all write it as a product of each individual radical. So in other words, use the product rule, the product property. So this becomes the square root of x to the 19th, square root of y to the 22nd. Okay, now we're gonna simplify. I can simplify both of those, right? Because 19 is greater than or equal to the index 2. 22 is greater than or equal to 2, so I can simplify both. So let's go off to the side and do the first one. Square root of x to the 19th. 19 is not divisible by 2. So remember this property, the rational exponent rule. So x to the a divided by b. Okay, so you all know that this means the same thing as x to the 19 divided by 2, right? Okay, just using the exponent divided by the index, just using the rational exponent rule. All right. So, but 19 is not divisible by 2. So 19 divided by 2 is not an integer. So I got to think about this a different way. So here's the way we're going to think about it. What is the largest integer less than 19 that's divisible by 2? And the answer is 18, right? 18 is divisible by 2. So I'm going to rewrite this as the square root of x to the 18th times the square root of x, right? Let me go ahead and do this. The square root of x to the 18th times x. Multiply like bases, you add exponents. 18 plus 1 is 19. And I'm going to rewrite this as square root of x to the 18th times the square root of x. Okay, now let's simplify this. I can simplify this because 18 is greater than or equal to 2. So the square root of x to the 18th is x to the 9th, right? 18 divided by 2 is 9, and always check yourself. Always check yourself, right? Always check yourself. X to the 9th times x to the 9th is x to the 18th, which is what you wanted. So that's what this means. Now, square root of x. Can I simplify the square root of x? The answer is no, because the exponent 1 is less than the index, so that cannot be simplified. So the square root of x to the 19th is this. So that goes here now. Okay? So that's x to the 9th, square root of x. Okay. Now let's talk about the square root of y to the 22nd. Okay, that's a nice one though, right? So there's really nothing to do for that one, y'all agree? 22 divided by 2 is what? 11. So that becomes times y to the 11th. So this is this, and this is this. And it kind of makes sense because look, y to the 11th times y to the 11th, when you multiply like bases, you add exponents, that's y to the 22nd, which is what we needed the radicand to be. But here's how you're going to write your answer. Always put the radical part on the end. Put the radical part on the end. So I'm going to write this as x to the 9th, y to the 11th, square root of x. So that's how you're going to write it. Put the radical on the end. Put the radical expression on the end. Okay. And I'll put these in alphabetical order, x, y. All right, and there's your answer. Okay? And then always check yourself. Always check yourself. 19. See, now you don't have to check yourself with this one because 22 is divisible by 2. But this one is not. So let's talk about 19 divided by 2. So 19 divided by 2 is 8.5, right? I'm sorry, excuse me, 9.5. 9.5, right? So that 9 is this here. Now see that? So this 9's this. The numerator is that exponent, so x to the first, and the 2 is your index. All right, so always check it like that. Always check it. Use that to help you to check this. All right, number 4. So let's go number 4. And number 4, we have um, the square root of x to the 11th, y to the 13th, z to the 8th. All right, and so now using the product property, based on the product property for radicals, I know I can rewrite this as the square root of x to the 11th, square root of y to the 13th, and this times the square root of z to the 8th. So I can write this as a product of each individual square root. And I also know I can simplify each of those, right? Each of those can be simplified because 11, the exponent, is greater than or equal to the index. 13 is greater than or equal to 2. Greater than or equal to 2. 8 is greater than or equal to 2. So I can simplify each one. This is the easier one because 8 is divisible by 2. But 13 is not divisible by 2, and 11, that's 11 here, 11 is not divisible by 2. Okay? So let's do the square root of 11 first. All right, remember how I want you to think about this. Think about it this way. What's the largest integer less than 11 that's divisible by the index, which is 2? The answer is 10. So I get the square root of x to the 10th times x, right? When you multiply like bases, you add exponents. So this becomes the square root of x to the 10th times the square root of x using the product property. Now what's the square root of x to the 10th? 10 divided by 2 is 5. So that's x to the 5th. Can I simplify the square root of x? No, because 1, the exponent 1, is less than the index. So that is this. So right underneath here, put what you just found. So that is x to the 5th square root of x. Now let's talk about the square root of y to the 13th. So the square root of y to the 13th. So let's do the same thing. I can simplify that because 13 is greater than or equal to the index 2. So what's the largest integer less than 13 that's divisible by 2? The answer is 12. So I can rewrite this as the square root of y to the 12th times y. Using a product property, this becomes the square root of y to the 12th square root of y. 12 is divisible by 2, so that now becomes y to the 6th. So this is y to the 6th square root of y. And I cannot simplify the square root of y because 1 is less than 2. So this part here, now this part here, I'm going to put a times here. That part here is this, y to the 6th square root of y. Okay? And then this part, this is the easier one because 8 divisible by 2, so the square root of z to the 8th is just z to the 4th. All right, now that's where I'm at. Okay? So very simple process. And always check yourself. All right, so watch. 11. Let's use a shortcut first. And let me use this. So 11 divided by 2. 11 divided by 2 is 5 and 1/2. So the 5 is this exponent of the outside. The numerator is the exponent of the variable. The denominator is your index, square root. Okay, 13 divided by 2. 13 divided by 2 is 6.5, right? So 6, you see it? That's that exponent here. And then the numerator, 1, is your index, y to the 1st. Okay? All right. So that's using a shortcut. Now, here's how you want to write the answer. Okay, so you all know that the square root of x times the square root of y, see that? Since the indices are the same, you can write it as one square root by multiplying the radicands together. So that's the square root of xy. All right, so put the xy, the square root of xy on the end. So we're going to have x to the 5th times y to the 6th times z to the 4th times the square root of xy. There's your answer. Okay? All right. Let's look at number 5. Okay, number 5. Let's suppose we had this for number 5. All right, number 5, we have the square root of 64 x y to the 9th. Square root of 64 x y to the 9th. Okay, so this time you see there's a coefficient other than 1. All these others had had coefficients of 1. So you can think of this as a 1. 1 times x to the 19th, y to the 22nd. 1 times x to the 11th, y to the 13th, z to the 8th, and so on. Okay? So it's a very easy process. Using the product property, I can rewrite this as square root of 64, the square root of x, square root of y to the 9th. All right. The square root of 64, you all know since 64 is a perfect square, the square root of 64 is 8. Can I simplify the square root of x? No. So I'm going to rewrite that. Now I can simplify the square root of y to the 9th because the index the exponent is greater than or equal to the index 2. So let's go ahead and talk about that. Square root of x to the 9th. So remember the process. Ask yourself, what is the largest integer less than 9 that's divisible by the index, which is 2? The answer is 8. So this becomes the square root of x to the 8th times x. So rewriting this using the product property, that's the square root of x to the 8th times the square root of x. So the square root of x to the 8 divided by 2 is 4, so that's x to the 4th, and then the square root of x. So I cannot simplify the square root of x for the same reason I couldn't simplify it here. I'm sorry, that's y, excuse me. That's y. All right. Okay, so that's y to the 8th. So that's going to be y to the 4th times the square root of y. Okay, so this is y here. All right, so this is this. So that's y to the 4th times the square root of y. All right, now remember, don't leave your answer like this. You are expected to know that the square root of x times the square root of y, since the indices are the same, square root, you can write as 1 square root. So put that in the end. So we're going to put the coefficient first. Always put the coefficient first. Then we're going to put y to the 4th. And then we're going to have square root of xy. And there's your answer. Okay, number 6. Number 6, we have the square root of 32, x squared, y to the 5th. That's a y. So the square root of 32, x squared, y to the 5th. Again, using a product property, it helps to rewrite it this way. The square root of 32, square root of x squared, square root of y to the 5th. Okay? All right, now, remember, the square root of 64 is a perfect square. Remember, 32 is not. There's no integer times itself that's 32. So we got to simplify the square root of 32. If you can simplify the square root of 32, and you can, the largest perfect square that goes into 32 is 16. So I can rewrite this as square root of 16 times the square root of 2. And the square root of 16 is 4, so I get 4 square root of 2. So this part is 4 square root of 2. Okay? Now, can I simplify the square root of x squared? Yes, because 2 is greater than or equal to the index 2. It's equal to. So 2 divided by 2 is 1. So that's just x. So this is just x here. Times. Can I simplify the square root of x of y to the 5th? Yes, because the exponent is greater than or equal to the index. So let's do that. So y, that's a y to the 5th. All right, so remember how to do this. You ask yourself, what's the largest integer less than 5 that's divisible by the index 2? So that's 4. So it'll be square root of y to the 4th times the square root of y, right? When you multiply like bases, you add exponents. And so we know that the square root of y to the 4th is y squared. So you get y squared, square root of y. So that goes here now. See how I'm doing it step by step? That's important in terms of your rationalization. Step by step. So that's y squared, square root of y. All right, and now I'm going to underline the square roots. Square root of 2, square root of y. Okay? So we know this. I want you to remember this. We know that the square root of 2 times the square root of y can be rewritten. Since the indices are the same, they're both square roots, we're going to write this as square root of the product of the radicands, 2 times y. All right, so I'm going to put that on the end. So that means I'm going to write 4 times x times y squared. So 4x y squared times the square root of 2y. And that's it. So this very simple process. It's not difficult at all. Okay, now let's go to number 7. So number 7, um, I think we have enough room here. In number 7, we have the square root of 108, square root of 108, x to the 24th, y to the 18th. Square root of x to the 24th, y to the 18th. Okay? By the product property, I know, and it helps if you rewrite this. I can write this as square root of 108 times the square root of x to the 24th times the square root of y to the 18th. All right, 108 is not a perfect square. So and you may need your calculator for this, so use your calculator if you have to. So the perfect square, the largest perfect square that goes into 108, and you got to try it. So you may say, well, what about 9? All right, well, let's try 9. All right, so 108 divided by 9, right? Okay, so 108 is divisible by 9, but notice it's not the largest. So you know it's not the largest. It's not the largest because, see this 12? What other perfect square goes into 12? 4. So 4 times 9 is 36. That means that 36 is the largest. So watch. 108 divided by 36 equals, and then 3, the only perfect square that goes into 3 is 1. So 36 is the largest. So I'm going to go off to the side and I'm going to rewrite the square root of 108 as the square root of 36 times the square root of 3. And always check yourself, 36 times 3 is 108. And then the square root of 36 is 6, so this becomes 6 square root of 3. So that goes here. See how I'm doing it step by step? It's important. 6 square root of 3. All right, now I can simplify the square root of x to the 24th. Okay, so always ask yourself, can I simplify that? Yes, because 24 is greater than or equal to 2. But this is a nice one because 24 is divisible by 2. So 24 divided by 2 is 12. So that's x to the 12. All right. Now remember, you also have to think this. You got to think, okay, well that's true. That's true because x to the 12th times x to the 12th is x to the 24th, which is what the square root of x to the 24th means. What times itself is x to the 24th? Okay, same thing here. That's a nice one, right? 18 is divisible by 2, so that's 9. But how do I write the answer? Here's how you have to write the answer. Put the radical on the outside. So this becomes 6 x to the 12th, y to the 9th, times the square root of 3. That's how we prefer the answer be written. Put the radical on the outside. All right. Okay. So that was number 7. Number 8. Let's look at number 8. Okay. Number 8 is this. All right. Number 8. We have the square root of 27, x to the 9th, y, z to the 10th. So the square root of x to the 9th, y, z to the 10th. All right, using the product property, this becomes the square root of 27, square root of x to the 9th, square root of y, square root of z to the 10th. Okay? Now, can I simplify the square root of 27? Well, what perfect square goes into 27? That's correct, 9. The largest perfect square is 9. So that'll be the square root of 9 times the square root of 3. And the square root of 9 is 3, so this becomes 3 square root of 3. So I'm going to rewrite under here. See how I'm underlining this like that? I'm going to say, well, that's going to be 3 square root of 3. Do it like that, step by step. Square root of x to the 9th, can I simplify that? Yes, because 9 is greater than or equal to 2. But 9 is not divisible by 2. So I got to think about that. Square root of x to the 9th. I remember how we thought about that. What is the largest integer less than 9 that's divisible by 2? Okay, 8. So I'm going to rewrite this as the square root of x to the 8th times x, right? When you multiply like bases, add exponents. But using the product rule or the product property, I can write this as square root of x to the 8th times the square root of x. Now let's simplify. 8 is divisible by 2, so that's 4. So the square root of x to the 8th is x to the 4th. Makes sense because x to the 4th times itself is x to the 8th. I cannot simplify the square root of x because the exponent 1 is less than the index. So that goes here. So time, and put a little times here. So that's times x to the 4th square root of x. Okay? Then times, can I simplify the square root of y? Nope. So rewrite it, right? The exponent is less than the index. Okay. What about the square root of z to the 10th? I can simplify that because 10 is greater than or equal to 2, but it's a nice one, isn't it? 10 is divisible by 2, so what's the square root of z to the 10th? 10 divided by 2 is 5, so z to the 5th. Okay? All right, now, you want to leave your answer like this? The answer is no. You leave it like this, you're not going to get full credit because you have to know that the square root of, I'm going to underline in red, the square root of 3. So if you have to underline these square roots, the square root of 3 times the square root of x times the square root of y. So here's what I have. I want you to think about what we have here. The square root of 3, square root of x, square root of y, right? So you see how you're multiplying radicals where the indices are the same, square root, square root, square root. So I can write this as 1 square root just by multiplying the radicands together, 3xy. All right, and that's going to be in the end. So now I'm going to write everything else in front. So 3, x to the 4th, z to the 5th, times the square root of 3xy. Very simple, isn't it? Very simple process. All right, now up to number 8, all we dealt with was square roots. Okay, let's do a cube root. Let's look at number 9. Okay, number 9. So we have the cube root of x to the 8th. Now this time it's cube root. Okay, same idea applies. I'm going to ask you, can I simplify this? You have to know yes or no right away. Can I simplify this? The answer is yes, because the exponent is greater than or equal to 3. The index is 3. All right. Now, this is a nice one in it. Is 8 divisible by 3? Actually, it's not a nice one. Is 8 divisible by 3? No, right? So 8 is not divisible by 3. So we got to figure this out. And remember how I told you to do this. Remember how we did this one? What's the largest integer less than 9 that's divisible by 2? The answer is 8. What's the largest integer less than 8 that's divisible by 3? So if you're not careful, you're going to say 7 because you saw, well, I just subtract 1. Is 7 divisible by 3? No. What's the next one? 6, right? Okay, good. So it'll be the cube root of x to the 6 times x squared. Make sure you understand why I got that x squared. When you multiply like bases, you add exponents. So if this is 6, 6 plus 2 is 8. Okay? Now I'm going to rewrite this using the product property. So as a cube root of x to the 6, cube root of x squared. Okay? Now, I can simplify the cube root of x to the 6 because 6 is greater than or equal to 3, and it's good. It's a nice one because 6 is divisible by 3. So the cube root, I want you to think about this, the cube root of x to the 6 is x squared, right? X squared, right? 6 divided by 3 is 2. So it's x squared because x squared times itself 3 times the index 3. 1, 2, 3. When you multiply like bases, add exponents. 2 plus 2 plus 2 is x to the 6, which is what this was. Okay? Use these thought processes to help you. So this is x to the 6. Now, can I simplify the cube root of x squared? No, because the exponent 2 is less than the index. So I'm just going to rewrite it. Cube root of x squared, and there's your answer. All right, let's look at number 10. So the more you do, the better you become at it. It's not a difficult process. Your thinking is not a difficult thing to deal with here. It's very easy. Cube root of x to the 9th, y to the 13th. Cube root of x to the ninth, y to the 13th. Okay, first thing you always want to do to help yourself through these thought processes is this. Use the product property. So this becomes the cube root of x to the ninth times the cube root of y to the 13th. And notice I can simplify both. I can simplify both because 9 is greater than or equal to 3. 13 is greater than or equal to, I'm sorry, that's the cube root right here. Don't forget the cube root is greater than or equal to 3. See, if I left it off, that would mean square root, right? Okay, so be careful. Okay, now let's simplify this. This one's the easy one, isn't it? Because 9 is divisible by 3. So 9 divided by 3 is 3. So this becomes x cubed. Make sure you understand why that's true. It's important because, and I'm going to go right here, because x cubed times itself 3 times, because the index is 3, so 1, 2, 3, is 9. When you multiply like base, you add exponents. 3 plus 3 plus 3 is 9, so you get x to the 9th. All right, now remember how we did this one. Now this one you got to think about. 13 is not divisible by 3, so you got to think about this. Cube root of y to the 13th. All right, here's how you think about this. Remember, you're dealing with 3 now. What's the largest integer less than 13 that's divisible by 3? And if you need to use your calculator, use your calculator. Use your calculator. So you may say, well, I'm going to look at 12. All right, well, is 12? I'm going to do this. Look, watch. Is 12 divisible by 3? Yes, because I get an integer. So it's 12. So I'm going to rewrite this as the cube root. Don't forget, you say cube root, though. If you leave it off, that means square root. Cube root of y to the 12th times y, right? Multiply like bases, you add exponents. So you see how I'm writing this? It's important. It's important when you begin your study on this to do it like this. Otherwise, your thought process will be disorganized and you're going to get some error and you're not going to learn it the way you need to learn it. All right, then I'm going to use a product property. So that's a cube root of y to the 12th times a cube root of y. Can I simplify this? You know it. 12 is greater than or equal to 3, right? And it's a good one too because 12 is divisible by 3. So what's 12 divided by 3? 4. So that's y to the 4th. Can I simplify this? You know it as well. The answer is no, right? Because y to the first power, 1, is less than the index. So that's the cube root of y. So that goes here. Okay, this. So you see I'm doing times right now. So times y to the 4th times the cube root of y. All right, and we always put the radical in the end. Well, the only radical I see is this one, so I'm going to write the answer as x cubed y to the 4th times the cube root of y. Okay? And that's it. That's all you do. Let's look at number 11. Let's do another one. Number 11. Let's do another cube root. Cube root of a to the 10th, b to the 20th times c. So the cube root of a to the 10th, b to the 20th times c. All right, so let's use a product property for radicals. So I can rewrite this as a cube root of a to the 10th times the cube root of b to the 20th times the cube root of c. See how that's done? Okay. I can simplify this. I can simplify this. I cannot simplify this, right? Because c to the first, 1's less than the index. All right, so we know we can simplify these, and 10 is not divisible by 3, and 20 is not divisible by 3. So some work we got to do, right? Some work we have to do. So let's do the first one. Cube root of a to the 10th. So what's the largest integer less than 10 that's divisible by 3? Yeah, 9. So you can rewrite this as the square root of cube root of a to the 9th times the cube root of a, right? 9 plus 1 is 10. So this, I can simplify this. 9 is divisible by 3, so that's a cubed. I cannot simplify this cube root of a, so I'm going to rewrite it. Cube root of a. So that goes here, okay? So that, I'm going to put this underneath. So that's a cubed, cube root of a. So I simplified this with this now. Now times, let's work on this one. So that's the cube root of b to the 20th. What's the largest integer less than 20 that's divisible by 3? So you may say, well, I'm going to try 19. All right, try 19. Look what happens. 19 divided by 3. Is that an integer? No, it's not an integer. It's a decimal. Okay, so let's try 18. 18 divided by 3. Yep, there you go. 18, right? So the cube root of b to the 20th I can write as the cube root of b to the 18th times the cube root of b. Now remember, what's that exponent? 18 plus what is 20? The answer is 2. Good. So I can simplify this. 18 divided by 3 is 6. So that'll be b to the 6. Kind of makes sense, right? Because b to the 6 times itself 3 times is b to the 18th. I cannot simplify this because 2 is less than 3. So I'm just going to rewrite this over. That's a b and that's a 6, by the way. So cube root of b squared. So that goes here. So b to the 6 times the cube root of b. And we said a while ago we could not simplify this. I'm going to rewrite this as times the cube root of c. Okay, so that's where I'm at. Now you all know, don't leave your answer like this because you see a cube root of a cube root of b, and a cube root of c, don't you? And we all know now, that the cube root of a times the cube root of b times the cube root of c can be rewritten as one cube root. And all you do is multiply the radicands together. So it'll be a, b, c. So the answer will be a cubed b to the 6 times the cube root of a, b, c. Okay? That's how you write it. Very simple process in it. Very simple. Let's look at number 12. Let's do another one. So it's getting pretty easy in it. Number 12. Number 12, let's suppose we had the cube root of 128 a to the second power. Cube root of 128 times a to the second power. All right. Now by the product property, I know I can rewrite this as a cube root of 128 times the cube root of a squared. Okay, so let's talk about the cube root of 128. Let's talk about that right here. Now be careful, that's not square root, that's cube root. So you got to ask yourself, what perfect cube goes into 128 evenly? Now remember, your perfect cubes are 1. The next one is 8. Remember how you get those. 1 cubed, 2 cubed, 3 cubed, 4 cubed, and so on, right? So 2 cubes 8, 3 cubes 27, 4 cubes 64, and so on. Okay? So 1 goes in everything. So let's try 8. Let's see if 8 works. So 128 divided by 8, 128 divided by 8 equals 16. Okay? So, and then the only perfect cube, and notice, doesn't 8 go into 16 as well? So is 8 the largest perfect cube? No, because 8 goes into 16 also. So that 8 times this 864. So watch, 128 divided by 64 equals 2, and the only perfect cube that goes into 2 is this 1. Okay, so this becomes the cube root of 64 times the cube root of 2. 64 times 2 is 128. We now know that the cube root of 64 is what? 4, right? Because 4 times 4 times 4 is 64. And then times the cube root of 2. So that goes here. 4 times the cube root of 2. Can I simplify the cube root of a squared? No, you cannot simplify that because 2 is less than 3. So I'm going to rewrite this as times the cube root of a squared. All right, now again, don't leave your answer like this because you're expected to know that the cube root of 2 times the cube root of a squared. Okay, look, cube root of 2 times the cube root of a squared, I can write as 1 cube root 2a squared. Okay, so I get 4 times the cube root of 2a squared. And there's your answer. Okay, so 4, that's a 4, times the cube root of 2a squared. Okay, 13, we're almost done. 13, this time let's look at a fourth root. Let's do a fourth root. Okay, fourth root of a to the 15th, b to the 18th, c to the 19th. Fourth root of um, a to the 15th, b to the 18th, c to the 19th. All right, so by the product property, I can write this as the fourth root of a to the 15th times the fourth root of b to the 18th times the fourth root of c to the 19th. All right, make sure, again, make sure you see your index. Make sure your indices are correct. Okay, so I can simplify each one of those. You see that now because 15 is greater than or equal to 4, 18 is greater than or equal to 4, 19 is greater than or equal to 4. Okay, so let's simplify each one. So the fourth root of a to the 15th. Don't make this difficult. Okay, so you're asking yourself, you know that 15 is not divisible by 4. You can see that 15 divided by 4 is not a whole number, right? Okay, so you got to think of what's the largest integer less than 15 is divisible by 4. So you may say, well, let's try 14. 14 divided by, 14 divided by 4 is not correct because it's not a whole number. You get 3.5. So let's try 12, right? 12 divided by 4 is 3. There you go. So I'm going to rewrite this as the fourth root of a to the 12th times the fourth root. Sorry, I messed up here. Fourth root of a. Now you can be careful, though. It's not a, right? 12 plus what is 15? Let me rewrite this. So it'll be the fourth root of a to the 12th times the fourth root of a to the third, right? 12 plus 3 is 15, so be careful. I can simplify this. 12 divided by 4 is 3, so that's a cubed. Now, make sure you understand why that's true. Y'all know that the fourth root of a cubed, fourth root of a to the 12th is a cubed, right? Because a cubed times itself 4 times, the index 4, is a to the 12th. When you multiply like bases, add exponents. 3 plus 3 plus 3 plus 3 is 12. Okay. Can I simplify the fourth root of a to the third? The answer is no. 3 is less than 4. So it becomes the fourth root of a cubed. So that goes underneath here. So a cubed, fourth root of a cubed. Okay? All right. Now, times. Let's do fourth root of b to the 18th. The fourth root of b to the 18th. Okay, so what's the largest integer less than 18 that's divisible by 4? Is 17 divided by 4? No. Is 16 divided by 4? Yes. So it'll be the fourth root of b to the 16th times the fourth root of b to what power, though? Be careful. You need to make sure that's correct. 16 plus what is 18? The answer is 2. When you multiply like bases, you add exponents. 16 plus 2 is 18. Now 16 divided by 4 is 4, so that's b to the fourth. Can I simplify the fourth root of b squared? The answer is no, because 2 is less than 4. So it'll be the fourth root of b squared, and that goes here now, okay? Underneath, so this right here is this. So that's times b to the fourth times the fourth root of b squared. Times, okay, let's do the fourth root of c to the 19th. I'm going to do that here. Fourth root of c to the 19th. So what's the large? I can simplify this because 19 is greater than or equal to 4. What's the largest integer, though, less than 19? That is divisible by 4. The answer is what? Is it 18? No. Is it 17? No. Is it 16? Yes. So see, y'all agree that the fourth root of c to the 19th is a fourth root of c to the 16th times c, and then 16 plus 3 is 19, right? And then by the product property, I can rewrite this as the fourth root of c to the 16th times the fourth root of c cubed. And 16 divided by 4 is 4, so that's c to the fourth. The fourth root of c cubed, I cannot simplify because 3 is less than 4. So I'm going to have to just rewrite it as that. And so that goes here. So c to the fourth times the fourth root of c cubed. Again, that's not the answer. Don't say that's the answer. You're going to be upset because you're expected to know that the fourth root of a cubed times the fourth root of b squared times the fourth root of c to the fourth. I'm writing it here. You're expected to note that the fourth root of a cubed times the fourth root of b squared times the fourth root of c cubed is the fourth root. So you can, since the indices are the same, you can write as one radical. So it'll be the fourth root of a cubed, b squared, c cubed. And I'm going to put these in front. So that becomes a cubed, b to the fourth, c to the fourth, times the fourth root of this radicand. So that's a cubed, b squared, c cubed. Okay? It is not difficult at all. You can get this. Okay, I know we spent quite a bit of time on this, but it's important that I do quite a few examples for you, so that way you can. The more you see and the more you do, the better you become at it. Let's do 14. 14. Okay, 14. We have the fourth root. Let's do another fourth root of 162. A to the 12th. B to the 15th, C to the 24th. Okay? All right. Okay, so using a product property, I can rewrite this as the fourth root of 162 times the fourth root of A to the 12th times the fourth root of B to the 15th times the fourth root of C to the 24th. Okay? Now let's talk about the fourth root of 162. So let's go off to the side and ask ourselves what that is. All right, now this time you're dealing with fourth root. So you're looking for an integer, okay, a perfect fourth that that goes into 162 evenly. All right, so here's the way I would do this. All right, so let's think about this. Let's look at the way I would do this is this. So this is hard to deal with because it's fourth. So 2 to the fourth, 3 to the fourth, 4 to the fourth. Let's just look at those. So let's see what 2 to the fourth is. So 2 to the fourth, 2 raised to the fourth, 2 raised to the fourth is 16. Okay? So this is a perfect fourth. 3 to the fourth is 81. 4 to the fourth is 256. So I know that since 256 is bigger than 162, I'm going to try one of these. They may or may not go into this. If it doesn't, then that means that I cannot simplify this. All right, so let's try 81 first. Is 162 divisible by 81? I'm sorry, 162. 162 divided by 81. There we go. Yes, right? So the fourth root of 162, the fourth root of 162 is the fourth root of 81 times the fourth root. 81 times 2 is 162 times the fourth root of 2. And the fourth root of 81, the fourth root of 81 is this 3 right here. Okay, and you can check it. Watch. Remember how to do this in your calculator? Remember this little symbol right here? That symbol that looks like X root right here? Make sure you know how to use a calculator. So I got to press 4 though first. So I got to press 4 and then I got to press second and then that symbol. See how it looks? This is this. So that 4 means fourth root and then put 81 and then notice you get 3. Okay? So this right here becomes 3 times the fourth root of 2. So this right here, the fourth root of 62 is 3 fourth root of 2. Now I can simplify this because 12 is greater than or equal to 4. In fact, it's an easy one because 12 is divisible by 4. So the fourth root of a to the 12th is a cubed. 12 divided by 4 is 3. Okay? 15 is not divisible by 4, so I got to work that out. So let's do that here. Let me write it here. Fourth root of a to the 15th. What's the largest integer less than 15 that's divisible by 4? Well, the answer is 12. So it becomes the fourth root of a to the 12th times the fourth root of a cubed, right? 3 plus 3, 12 plus 3 is 15. 12 divided by 4 is 3, so I can simplify that. So that's a cubed. I cannot simplify this because 3 is less than 4. So it'll be the fourth root of a cubed. So that goes here. So times a cubed, fourth root of a cubed. I can simplify this, couldn't I? And it's a nice one because 24 is divisible by 4. 24 divided by 4 is 6. So it'll be times c to the 6. And by the way, I'm sorry. I meant that that's not the fourth root of a. That's the fourth root of b. Excuse me. Sorry. That's b right here. B, b. These are all b's. So that should be a b. And that should be a b. Excuse me. See that b right here? Okay, now we all know how to rewrite this. Fourth root of 2, fourth root of b cubed. So this becomes, and always put that in the end, put the radical in the end. So you get 3a cubed b cubed c to the 6 times the fourth root of 2b cubed. And there's your answer. Okay? All right, one more. And here's why. Let's do the fifth root. The fifth root of a negative 32, x to the 30th, that's a 30, y to the 31st. Okay? All right. Now, using the product property for radicals, I know I can rewrite this as the fifth root of negative 32 times the fifth root of x to the 30th times the fifth root of y to the 31st. Now, the fifth root of negative 32. Now, so you see how we did this one right here? Let's do that same idea. Let's look at 2 to the 5th. So 2 to the 5th is, use your calculator if you got to, 2 to the 5th is, well, there it is, 32. So that's we already have it. So the fifth root of 32, so that means this, the fifth root of 32 is 2. Okay? Now be careful though, that's negative 32. So the fifth root of negative 32 is a negative 2. Now don't say not a real number because that's an odd index. All right, now if this was a square root of negative 32, then that would be not a real number. But negative 2 times itself 5 times is negative 32. Okay? So that's negative 2. So this is negative 2. I can simplify this. In fact, it's an easy one. 30 is divisible by 5. So 30 divided by 5 is 6. I can simplify this, but it's not as easy, so I have to figure that out. So let's do that here. So the fifth root of y to the 31 was the largest integer less than 31 that's divisible by 5, and the answer is 30. So that becomes the fifth root of y to the 30th times the fifth root of y. 30 plus 1 is 31. And 5 divided by 30 is 6, so that's y to the 6 times the fifth root of y. And so I'm going to put that here, so that is this, y to the 6 times the fifth root of y. And then just rewriting this a little bit better, so it'll be negative 2 x to the 6 y to the 6 times the fifth root of y. And that's it. So it's a very simple process. It's not a difficult topic at all. Okay? So that is simplifying radicals containing variables.